Solutions for final exam, third 9 weeks. A chemical reaction occurs when 40 grams of solid ammonium phosphate, or NH43PO4, is added to 100 milliliter 2.6 molar solution of calcium nitride. The first question is asking you to find the molar mass of ammonium phosphate. Okay, so molar mass is relatively simple. You take the compound that you're working with. In this case, it's ammonium phosphate. Okay, and then you just figure out how much it weighs. So for this one, what I'm going to do is I'm going to list all the elements that I see: nitrogen, hydrogen, phosphorus, and oxygen. Okay, then I'm going to see how many there are of each one. So nitrogen, this 3 affects both. So there's 3 nitrogens. 3 times 4, there's 12 hydrogens. There is 1 phosphorus, and there's 4 oxygens. Okay, then I'm going to multiply those numbers by their atomic masses on the periodic table. So 14.0067 is the atomic weight or atomic mass of nitrogen. Hydrogen is 1.008. Phosphorus is 30.9737. Okay, and then oxygen is 15.9998. Okay. All right. Once I figured out their atomic masses from the periodic table, okay, I'm going to just multiply. All right. So 14.0067 times 3 is equal to 42.021. 12 times 1.008 is 12.096. 30.9737 times, of course, it's 1. Didn't need a calculator for that. Okay, and then 4 times 15.99 is equal to 63.996. Okay. Once I figured all this information out, then all I have to do is add everything up, right? So if I add everything up, I should get a total. So let's see. Okay, so I'm going to add to that the 12.0 or the 30.97. Let's see. Plus the 12.096 plus the 42.01. 63.996. Oops. 30.97. 37. Okay, so for this one, you should get a total mass of 149.086. Okay, so that's pretty simple. All right. You do the same thing for calcium nitrate, nitride. Real quick. Okay. So let's take a look. Let me scroll this up just a little bit. Okay. So this one's a little bit different. Okay. So I got to figure out what calcium nitride looks like. All right. So now we go to our periodic table of ions, which you all guys have. So calcium nitride, okay, is here. Calcium nitride. Okay. So the first thing I got to do is I got to find calcium. So calcium, I can see here, has a chemical symbol of Ca, and that guy carries a +2 charge. See, it's right here. All right, and then I got to find nitride. Nitride is right here, okay? That has the chemical symbol of N, and that has a -3 charge. Okay, to make a compound, this guy becomes the subscript here. This guy becomes the subscript here, okay? And I get a chemical compound that looks like this. Okay, when you're looking for, when I give you the name of a chemical formula, a chemical compound, this is how you do the chemical formula. You use this table to figure out what the charges are, and then you balance out the elements. Okay, so now let's go ahead and find the molar mass of this compound. It'll be the same process as before. Okay, I'm going to list all the elements involved. In this case, it's just calcium and nitrogen. Okay, I'm going to go through and work this out. Okay. Okay, so here's a solution. Okay, I didn't want to sit there and have you watch me do the whole thing all over again. I found the atomic masses of each element, figured out how many of each element there are in the compound. There's 3 and 2, multiplied them, added them together, and I should end up with a final molar mass of 150.353. They're actually pretty similar. They're pretty close in their masses. Okay. Okay, guys. So that's how you do the molar mass. Let's go ahead and let's move on to the next question. Okay, the next question is asking us how many my goodness. Let me move this back up. It says how many moles of ammonium phosphate are present in this compound. Okay, so now we got to calculate moles. Okay, all right, do this in a different color. So question 1B. All right, moles. So we're going to do a mole conversion, and we're going to use this as the conversion factor. Okay, so we want to know about ammonium phosphate. All right, so according to this, we have 40 grams of solid ammonium phosphate. So we have 40 grams, and we need to convert that to moles. Okay, how do I do that? Well, anytime I see the word grams, okay, grams equals molar or atomic mass. Okay, lucky for you, you already have it. It's here. All right. So then all we got to do is use that as a conversion. Now, what this is telling you is that 1 mole of ammonium phosphate has a mass of 149.8086 grams of ammonium phosphate. Okay. So how do I use this as a conversion factor? Well, first I got to figure out how much I have. So I have 40 grams here of ammonium phosphate. Okay, I'm going to put that over 1. Then I'm going to multiply by the conversion factor. This right here, guys, is your conversion factor. Now you notice it's a conversion factor because I have a mole unit and I have a grams unit. What you got to figure out to set this up correctly is you got to figure out which one of these units is going to go right here at the bottom. All right, to answer that, whatever unit you have here, okay, is going to be the unit that goes here. So at the bottom, I'm going to put 149.086 grams of ammonium phosphate. And at the top, I'm going to put 1 mole of ammonium phosphate. Okay, when you do that, the grams of ammonium phosphate will cancel out. Okay. So then what do I do next? I multiply everything straight across the top, everything straight across the bottom. 40 times 1 mole gives me 40 moles of ammonium phosphate. And then I'm going to divide that by 1 times 149.086. That just gives me 49.086. Okay. And then once you get here, all you got to do is divide at the end. So 40 divided by 149.086 is equal to 0.268 moles of ammonium phosphate. Okay, and that's it. That's how you do the conversion. This is all review. And if you guys don't understand this, you need to make sure you learn it because you're going to be doing this a lot. Okay, so that's how you get the answer for 1B. All right, let's move on to question 1C. Question 1C is asking for how many moles of calcium nitride do you have? Now, you're probably thinking, well, we can do the same thing. Well, you can and you can't, okay? For calcium nitride is in a solution, all right? And it gives you this information here. It gives you 100 milliliters at 2.6 molar. So we just took notes on this the other day. Molarity is equal to the moles of the solute over the volume of the solvent, okay? This is the formula for a solution. Solution concentration. okay? M is your concentration and your molarity. We know that that's 2.6 molar because it's in the question. Moles, we don't know what those are. So that's the unknown, okay? And the volume, you have that. It's 130 milliliters, okay? Based on that, you should be able to calculate this one, right? It's 3 variables. If you have one that is unknown, then you should be able to solve for it. So how do I get V over here and get X by itself? Well, I multiply both sides by volume. So to find the number of moles, right, I take my volume and I multiply it by my molarity. Therefore, I take N is equal to 2.6 molar times 1.130 liters, okay? 2.6 times 0.130. And I know what you're thinking. You're thinking, hey, mister, you're making a mistake because it's 130, not 0.13. Yes, it is 130. You're absolutely correct. But calcium nitride. When you write this formula, the volume is equal to liters of the solution of solvent, right? In the solution. So if I have something in milliliters, in this case, 130 milliliters, I have to convert that to liters. How do I do that? It's simple. 130.0 milliliters to liters is the decimal over 3 times because there's 1,000 milliliters in 1 liter, right? So 130 milliliters is going to be 0.130 liters, which is why I used that value right here. All right. This is something that's fresh. All right. But we just took notes on this. You should have been able to solve that. All right. Next one, write the balanced chemical equation for the reaction above. All right. Let's go ahead and do that one. This is question number 2. So we know that we have ammonium phosphate and that's reacting with calcium nitride. What it's asking you to do here is say, okay, well, let's figure out what type of reaction it is and let's predict the products, right? So I can see here that this is going to be AB plus CD, which tells me that this is a double reaction, a double replacement. So when I have a double replacement, these two guys just swap places. So what happens is the calcium, instead of being bonded to, let me get rid of that. The calcium, instead of being bonded to nitrogen, is now going to bond to phosphate, right? So calcium has a 2+ charge that we saw earlier, and phosphate has a 3- charge, right? This guy becomes the subscript here. This guy becomes a subscript here, and you end up with calcium 3 phosphate. Okay. No, these numbers here do not carry over to the other side. If those numbers there carried over to the other side, then we would not ever need to balance, right? And the next one is going to be ammonium nitride. Okay, so that's going to be your balance or your chemical reaction. So now what we got to do is we got to balance it. Okay, go ahead and get rid of this stuff here so I can work. Now, again, because this is a video, please feel free to pause, to rewind, to watch something again. But I'm going to keep moving through. Okay, so to balance a reaction, all you got to do is list all the elements. So you have ammonium. Don't separate those because they're polyatomic ions, right? Phosphate, calcium, and nitrogen. Okay, then you go through and you list everything, the amounts that they have. So there's 3 here, there's 3 here. Let's see, Phosphate, there's one phosphate here. There's two phosphate here. Calcium, there's three. There's three. And then nitrogen, there is two nitrogens and one nitrogen. Okay, so let's figure out what we can work with first. Let's try and balance out the phosphates, right? Because these guys are out of balance. So I'm going to do that by putting a 2 right here. By putting a 2 right there, I change the phosphate to a 2, but I also change my nitrates to a 6, right? Because 2 times 3, right? All right. By doing that, let's go ahead and jump over to the other side of the phosphate here and see if we can bring this to a balance. By putting a 2 here, I change that to a 6, and I change the nitrogens to a 2. Okay. And if you look, that's pretty much all that we needed, right? We have 6, 6, 2, 2, 3, 3, 2, 2. This equation has now been balanced. So this is the answer for question number 2. Okay. All right. Let's go on to the last questions here. All right. Identify the mole ratio between the reactants. Okay. So let's go down to the balanced chemical equation here. Okay. In a chemical equation, this side of the equation is called the reactant side. This side of the equation is called the product side. Okay, so everything here are your reactants, everything here is your product. Now, what question 2A is asking for, right? It's asking for the mole ratio of the reactants. Well, my reactant is this guy here and this guy here. How do I get the mole ratio? Well, I take a look at the coefficients that are in front. Okay, if there's no coefficient in front, then we assume 1. So the mole ratio then is going to be 2 moles of ammonium phosphate for every 1 mole of calcium nitride. Okay, and that's it. A mole ratio is just, again, the ratio or the fraction of the big numbers, the coefficients that are in front of the compound in a balanced chemical equation. You cannot get the coefficients until you balance, right? So you can't find mole ratio without a balanced equation. And you can't balance equation until you calculate products. All right, so that was it. That was the answer for question 2A. 2B is asking for use the mole ratio to find the limiting reactant. Okay, so we need to use this mole ratio and we need to figure out which one is the limiting reactant of this equation. Okay, which one of the reactants, one of these two guys here, okay, is going to be consumed first. That's what we have to calculate. So let me go ahead and switch colors here. Okay, so for question 2B, the limiting reactant. Okay, the limiting reactant is going to be the reactant or compound that gets used up first. Okay, and then that's going to dictate how much product is formed. We'll get to that later, but for now, let's focus on the limiting reactant. All right, so I'm just going to pick one. All right, I already calculated the moles of each one. All right, so I'm just going to pick one of the values. All right, so I'm going to pick 0.338 calcium nitrate, right? Because that's the first one that I see. So 0.338 moles of calcium nitride. Again, this is the same number that we just calculated in the previous question. Put that over 1. Okay. Now I'm going to multiply that by the mole ratio. Okay. The mole ratio is this one. That's the mole ratio of the reactants. So I got to figure out which one of these goes at the bottom. Do I leave it the way it is or do I flip it? Well, because I have calcium nitrate here, I want calcium nitrate here. So I'm going to leave the mole ratio exactly the way it is. Now, let's say I had up here ammonium nitrate. If I had ammonium nitrate up here, then I would have to flip this mole ratio, right? But because we picked this one, as it happens, I can leave the mole ratio exactly the way it is, and I don't have to flip it. And the reason I can keep it is because now these units, since they're the same, they can just cancel. All right. Once I have it set up, I'm going to multiply everything across the top. I'm going to multiply everything across the bottom. So 0.338 times 2 is going to be 0.676 moles of ammonium phosphate. Okay, this tells me how much ammonium phosphate I need. This tells me how much ammonium phosphate I need. Okay, what I got to do now is I got to figure out how much I have. So remember, guys, that we actually calculated this amount, 0.268. 0.268. So 0.268 moles of ammonium phosphate. This is how much ammonium phosphate we actually have. Okay, so then you got to ask yourself, do I have more or do I have less than what I need? Well, I have less because this number is bigger, right? So right now I can say I have less than I need. If I don't have enough, then ammonium phosphate, right, is going to be my limiting reactant. If ammonium phosphate is my limiting reactant, okay, then calcium nitride is going to be my excess. Okay. Okay, guys, that's it. That's the solution for the test. If you have any questions, please let me know.